Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to implement a binary search tree. Our binary search tree is going to contain binary nodes. So we have these node objects that will have a left pointer and a right pointer that can point to other nodes, and it's going to have a data property which is going to be an integer. This is what's going to allow us to keep our tree sorted. We're going to implement this binary search tree object. It's going to maintain a reference to the root node of our tree, and then we'll add methods to insert and search for nodes. So here's an example of our binary node. The data is just going to be an integer, and in this case, we're also going to assume they're unique integers to make it simple. Then it can have a left and a right child. Our tree is going to have one attribute, which is a pointer to the root node. Then we'll have an insert method, which inserts an item and must maintain sorted order. We're also going to have a search method, which will look for an item in the tree. It's also worth noting that we're not going to enforce our tree to be balanced. We're just going to make sure it stays sorted, but we won't add any additional algorithms to create a balanced binary search tree. We will only have a binary search tree. So let's look at what happens when we insert an item. We take this value, and if any node is larger than that item, then we go left. If the node is smaller, then we go right. This is how we ensure we always keep our sorted order. Then, when we reach a null pointer, that means we found a leaf and can insert our value. For our search method, we perform a similar iteration. When we're looking for the node, we go left if it's smaller, and we go right if it's larger. If we find the value, we return it. Otherwise, if we hit a leaf, we return null. If our tree is balanced, then this will occur in O of log n time. If it's not balanced, well then it occurs in O of n time, linear time. That's because when you're making these moves left and right, when it's balanced, you'll cut out roughly half of the tree. When it's unbalanced, then it degrades to needing to iterate through all n items. And now we're ready to implement our binary search tree. We'll start with the insert method. First, we'll just convert this data to a node. New binary node of the data. Then we need to check if we have a root node yet or not. If we don't, then this node simply becomes the root. If the root is null, this.root equals node. Then we return this to have a reference to the graph. If we do have nodes in the tree, now we need to iterate through it and find the correct location for our node, which keeps the whole tree in sorted order. So what we'll do is start at the root. Then we're going to enter a while loop. We have no idea when we'll reach our node, so what we're going to do is just iterate while true, but then put return conditions inside this node and ensure that they'll terminate. So we're going to iterate through our tree node by node. We're going to update the current node to the left or right pointer, depending if the data we want to insert is larger or smaller. So if the data is less than the current node, then this means we want to go left. First, we want to check if we've reached a leaf node. This happens when we reach a null value. So isLeaf is if the current node .left is null. If we have reached a leaf, we found the first location where it's empty and we can put this item. So if it's a leaf, current node .left is now equal to this node. And then we return. Otherwise, we need to traverse left and continue walking through the graph. So current node is now set to the left value of the current node. If the item is larger, then we'll create an else block and check the right path. Now we'll check if we found a leaf and can insert to the right. if isLeaf current node dot right is now the node, and then we return. If we don't find a leaf, that means we just move right. So current node is now equal to current node dot right. And this is all we need to do. We continue to iterate left and right depending if the data we want to insert is smaller or larger. We know there have to be leaf nodes on the graph, so eventually it will terminate when we find a leaf. And this is also the point where we can insert our node. And now we'll implement our search method. The way we iterate is going to be similar. We'll move left and right depending on if the value we're looking for is larger or smaller. Then, once we find that value, we can return it. If we can't find it, then we return null. So first, we just want to check if our tree even exists. If we don't have a root, that means there are no items, and we can return null. If we do have a root, then we initialize our current node to the root's value, and then begin iterating from here. In this case, our while loop will have a condition. We iterate as long as our current node is not null. So if we do reach a null value, that means we couldn't find it, and we want to break our loop, and then we'll return null from this method. So if the data we're looking for is smaller than the current node data, then we move left. If it's larger than the current node's data, then we go right. And now we need to check if we found the node. If we can't go left and we can't go right, it's not larger or smaller. That means we must have found it. So let's just write a condition to confirm that. If the data is equal to what we're looking for. If that's true, then you return current node. If we reach a leaf node, we never find this data, our current node will become null. In that case, we'll break the while loop and just return null from the method. And that's the functionality we need to implement our binary search tree. And now, let's run our example. And now we've constructed a binary search tree using these values. We've correctly ordered them based on when it's larger and smaller than the data we're trying to insert or search for. So in this lesson, we've not only learned how to build a binary search tree, but we've learned how to iterate through it and also how to add items. This is going to be very helpful as you're going into your interviews and making you feel comfortable working with trees.